Okay, so this is a follow-on from my previous video where we looked at completing the square, and in this video we're going to be using the completed the square form to solve quadratic equations. So the first step is to complete the square, and then from this we're going to use it to find the solutions. So I'm going to go straight ahead into an example. We'll do x squared plus 8x plus 10, and this is equal to 0. So this is a quadratic equation, and we want to complete the square. So we're going to write down x, and then we look at the coefficient of the x term. This is 8, so we need to divide by 2, and this gives us 4. Then we square this, and now we need to subtract off the constant that these brackets would give if we were to expand them out. So we'd get 4 times 4, which is 16, so we subtract off 16. And this is exactly what this formula is telling us. And then last step is to not forget that we still have the plus 10 from before. So this carries through and we just write plus 10. And this is still equal to 0. So we can just collect the terms. This is x plus 4 squared. This is minus 6, but I'm just going to move it onto the other side. Write this as plus 6. So do this 2 steps in one step. We have minus 16 plus 10 is minus 6. Move it onto the right hand side. This becomes plus 6. And now we have a square term on the left hand side and a number on the right hand side, and we can go ahead and just take the square root. So this removes the square component of the equation, and we're going to be left with x plus 4 equals the square root of 6. So this doesn't actually simplify, so we're going to leave it in third form. And then it's really important not to forget the second solution to this equation. So plus is a solution, but also the negative number of this is a solution. If we were to go back upwards and square both sides of the equation, then minus square root 6, when you square that, that gives you 6 as well. So it's really important not to forget the second solution. And you might be asking, why have we only put plus or minus on the right hand side? Well, if we were to put it on the left hand side, it would be the same thing, because we can just multiply through by minus 1 and we have it back on the right hand side. So this is just convention. And then the last step is to move this number onto the right hand side. So we have x equals a number. So this gives us x equals minus 4 plus or minus root 6. Now what this plus or minus is telling us is basically that the plus version and the negative version are both solutions. So we can just decompose this as x equals minus 4 plus root 6. And so this is a solution, and x equals minus 4 minus root 6. This is also a solution. And these are both the solutions of the quadratic equation up here. So these are the numbers that will make this expression equal to 0. Okay, so as you've seen, this is a really powerful tool to solve the quadratic equation. It's basically a derivation of finding the solutions, and it's really powerful because you can apply it to any single quadratic equation. I'm going to do one more example just to solidify that we understand the method. We're going to do 2x squared minus 8x plus 7 equals 0. So now we've got a number in front of the x squared term, and we don't really want this because we can't really apply the completed the square straight away. So what we're going to do is just divide every term by 2, and this is going to give us x squared minus 4x plus 7 over 2, and because 0 divided by 2 is still 0, this is just equal to 0. So that's a nice property that we can use of 0. And now we just have the x squared, so we can use the completed the square formula. So what we do is we write x, then we look at the coefficient in front of x. This is minus 4, so we want to divide by 2. We write this as minus 2, and then we square this. And then the next step is to remember the constant that would come out of this bracket if we were to expand it out. We'd get minus 2 times minus 2, which is plus 4. So to make this balanced, we need to subtract off that number, so minus 4. And if you were to expand this out, we would get x squared minus 4x. So then we need to still remember the constant from before. So this constant minus 7 over 2, this follows through, and we just have this equal to 0. So now just as before, we're going to move the constants onto the right hand side. So I'll just write this as plus 4 minus 7 over 2. So I've just changed the signs, and now we want to simplify this. 4 is the same as 8 divided by 2, and then we still have the minus 7 over 2, and now everything's in the same denominator, so we can just add the numerators, and we have 8 minus 7, which is a half. So we have this quadratic, or this square number, equal to a half. So I'm just going to bring this up here so you can see. We have x minus 2 squared equals to a half. And then just as before, we can now take the square root. And then we get x minus 2 equals the square root of a half. And then we, just as before, we need to remember the plus or minus. This gives us the two solutions of the quadratic equation. So then the last step is just to move over the 2. We're going to have x equals 2 plus or minus the square root of a half. And another way you can write the square root of a half is as 2 over 2, the square root of 2 over 2. This is the rationalized form, but both numbers are acceptable. They both mean the same thing. So I'm just going to leave the solution in this form. So this is equivalent. This is saying that 2 plus square root of 2 divided by 2 is the solution, and 2 minus the square root of 2 over 2 is the solution. So these are both the two solutions and the only two solutions of this quadratic equation.